Hello, this is Shirley. Welcome to my demonstration video. Today, I am going to be demonstrating a t-test. A t-test checks two means or averages and sees if they are reliably different from one another. Now, a t-test and a z-test are very similar, but with a z-test, we always need the standard deviation, and that's not always accessible. So with the t-test, we do not. So this test is more available to us. All right, the first thing that I needed to do in order to get the ball rolling here on my t-test was I needed to prep my data. And so what I have here is I have the 3rd to 4th grade student performance raw data for the 2017-2018 school year. And I am going to be looking specifically at the raw reading score and what I needed to do to prepare my data. I eliminated things that I didn't need. I eliminated every grade but the 3rd grade. I did go ahead and separate by gender, male and female, because I thought that that was a good learning experience for me when I was doing my custom sort. I don't think I've ever added levels before, so that was fun to do, but really won't be necessary for our findings today. All right, so next, I am looking specifically at the Hispanic Latino students. So that is what I have. I just have my Hispanic students. And as you can see, as I scroll down, I am going to be looking at, okay, this is a trick question. Am I looking at 227 students? No, I am not. This tripped me up for about an hour. And finally, I remembered that I had labels in the first row. So I have the raw score for 226 students. Okay, so after I prepped the data, I went to the TEA website. And in the TEA website, I did a search for mean p-value for the star. And from there, I was able to select the technical digest for 2017 and 18. And then I went into it and picked my 2018 star English grade 3 test results. And I did a little screenshot of that, and I've inserted it right here. So this is the total population data. And as you can see in my overall reading test, the mean is 21.73 and the standard deviation is 6.78. And I have another little nightmare going on right here. I've got a 5 there for some reason. Let's correct that and put a 3 there. Okay, so I wanted to have the same things for my data that I will be using, my sample data. And so calculated the mean and just used the formula of average of all of my raw test scores and did the same thing for standard deviation. Use the Excel formula for that. And that is how I came up with these two numbers. All righty, moving on. The question that I'll be looking at now that we've got everything all prepped and ready to go is the raw score mean for the Hispanic population on the 2017-18 STAR reading test significantly different than the Hispanic population of a specific district? And so looking to see how the Hispanic population of a specific district, what their scores looked like by comparison to the populations. And so that is my question. Now, In order to do our t-test, we are going to use the 6 steps of hypothesis testing for a single sample t-test. And so I indicated those right here. All right, first thing we needed to do is to pick a test. And it is fortunate that we selected the single sample t-test because that's what we're demonstrating today. But it is the perfect test for this because we want to be able to compare a population mean with the mean of our district. So that is what we are going to be doing. And even though we do have the standard deviation for the sample data and for the total population data, we're going to pretend that we don't, because we would use the t-test if we didn't have the standard deviation. And so that doesn't exist, but we have it. Okay, so anyway, we've picked the test. All right, after that, moving right along, we needed to, step 2, check the assumptions. So assumption number 1, is this a random sample? And backing up the boat, we determine what our assumptions are based on the test that we're running. So for the t-test, these are the assumptions that we need to check. It is a random sample. It is independent of observation. And we wanted to make sure that the dependent variable was normally distributed. And so in order to do that, we needed to create a histogram and a box plot. So first thing I did was I created a bin range, and I just went right from the amount of, you could get 1 correct on down to 33 correct. So my bin range represents every single question on the test. And then using that bin range, we calculated the frequency. And with that came our histogram. And so here is the visual representation of the frequency and the number of test questions that were correct by X amount of students. Okay, the frequency that those were correct. I guess that's a better way to say it. All right, from that information, we created a data box plot, and we've got that right here. And this is another way to just eyeball the fact that yes, indeed, the dependent variable is normally distributed. So with that in mind, we're ready to move on. And step 3 is listing the hypothesis. So our hypothesis is going to be, is the population of, let me make sure I'm reading this correctly. Hang on 1 second. Okay. Yes. Okay. So the population of Hispanic scores, are they equal to the district's scores for the Hispanics? And then our alternate hypothesis is, are they not equal? All right, so we have our hypothesis and our alternate hypothesis. So we're going to be doing the 2-test non-directional. All right, step number 4. This is another step that is exciting to talk about. I'm looking to see if I've got my handy notes so that I say it correctly. And yes, I do. So step 4 is setting the alpha or the decision rule. And so this is the decision rule, is when to reject the null hypothesis or when to fail to reject the null hypothesis. And what we are going with here is our alpha is 0.05. And we got that information from our chart, our confidence interval percent for a 2-tell test. And here we are. In education, we are willing to, this is another thing that I wanted to say correctly. we had to say, how willing are we to risk making a type 1 error? We had to determine how willing we were. And again, in education, we're willing to have an error 0.05 or 0.05% of the time. Okay, so with that in mind, we're going to scroll down and begin to calculate our statistics. Okay, and this is where the information on the chart will be important to us, where we're calculating the statistics. Okay, so our sample size is 226, and our degree of freedom is 225. This is another thing that I really wanted to understand when I was working on this unit. And so if we have a sample size of 3, and we know the value of number 1 and number 2, the third value is not free to vary. That third value is going to be fixed. There's no degree of freedom there, because we need to equal the total that we get to in our sample size of 3. Okay, so here is our degree of freedom is 225. And then we also have our T critical value of 1.96. And we can see that we came up with that in our 0.05, scrolled all the way to the bottom. After 120, it goes to infinity, and that's where we've got our 1.96. Okay, and so we have everything that we need to calculate the statistics. So with that in mind, what I did was I selected data, and then I've got to move my face out of the way. All right, selected data, and then I went to data analysis. From there, I went to the t-test paired to sample for means. Okay, and my variable 1 range is the raw scores for the 226 students. And then my variable 2 range is actually some dummy scores. Uh-oh, what is happening? Oh, it won't let me scroll up because it's trying to help me get everything I need to run this Okay, so I'm at a loss of words. Okay, so as you can see, I can move it over here. These are my dummy scores. They are 0 from top to bottom, and I did need to have 226 of them in order to continue to run this. Okay, so yes, there were labels in the top row. My hypothesized mean difference is 21.75, and that was, now remember, it doesn't like it when I move things around, but we saw that in, oh wow, oh, it's getting excited. Oh, no. This is, see, I wanted to show where I got my 21.75 from, and in that instance, I lost my variable 2 range. So got to go back and pick that up. My variable 2 range comes from my dummy row. And there we have it. And then I've got my 21.75 for my hypothesized mean difference. And we said our alpha is set at 0.05, and I'm going to calculate this on a new worksheet. Already did that, but let's take a look at it. And it's feeling so hurt when it doesn't get to provide that data analysis. So here we have all of our data. All right, so I did a little screenshot of that and inserted it into all of our data so we could see everything together. Okay, so here we have our mean score, our variance, how many observations we had. We've got our degree of freedom, which is 225. And our t-stat is negative 0.478. And it goes on. And then our t-critical to tell is 1.97056. Okay, so having calculated the statistics, now we are going to interpret the results. So let's just scooch down a little bit. And so what we can see here is, again, if the population, the general population, by comparison to the district population, if their mean scores are equal, then we will fail to reject the null. But if they are not, then we will reject the null. And so because our t-score is 478, it's minus 0.478. It is smaller than the 1.96 p-value. It's smaller than that. 1.96 is greater. And so and 0.632 is greater than 0.05, and we get that 0.632 right here. Okay, and because of that, there is failure to reject the null. Okay, I drew it out for us. Here is the our t critical value, making sure I'm saying that right. Yes, our t critical value, 1.96, is charted right there on both sides. And this is where our t-stat is negative 0.48. It's inside of 1.96. So there is failure to reject the null. And since there is no difference, and our hypothesis failed to be rejected, the effect size is we don't need to calculate for it because we failed to reject the null. However, if we were going to be calculating Cohen's d, we would use these items to do it. And this formula, we've got a couple formulas that we need to go through, step 1 and step 2 of our formulas. And then we would come up with our effect size. And then here is the effect sizes in social and behavioral science. So many things happened here. So many things to calculate and to do and to remember and to use and work with. I hope that you have enjoyed this. I'm going to, let's see, well, I won't stop sharing yet. Here I am. Here's my face again. All right, so hopefully I said some things that were accurate and I did some things that were right. And hopefully you enjoyed this demonstration video. And so at this time, let's see if well, my face always gets in the way. At this time, I am going to end our recording. And I hope you have a wonderful day.